Okay. So what we're going to do is one practice calculation on the magnitude. Here we go. Oh, that gets brighter. So we're calculating the forces of universal gravitation. So here let's look at the magnitude. So we need two bodies, right? We need two bodies. Some distance. Oh, that was a horrible throw. I'm such a sports nut. Here, you grab it. You almost had it. You were in the gray sweatshirt there. You're far enough away. Oh, you can't reach it. Get up and get all your stuff out of the way. You don't have your shoes on. Fine. Okay, now here we go. So we are two bodies, right? Separated by 6 meters. Let me draw. We got to stay this way because we got to have this force going the whole time. And I'm going to try not to clothesline anyone, but I'm not making any promises, right? See, this is my favorite kind of demo because nobody has to come up here. This is my little space. You guys stay there. I will be here. This is me. This is you. Okay, so what we're going to do is calculate the force. The force between me, okay, well, let's do initials. What were your initials? Were they MD? JS. Force of JH and JS. 6.67 times 10 to the minus 11. What's the unit? Doesn't matter. Nobody can remember the unit. I'm going to say 70 kilograms, and I don't want to body shame anybody. I'll say 65. You can be 65. Okay, I'm 70. You can be 65. We won't get into that. And then the separation in meters, center to center. Hold it at your center. There we go. 6 meters squared. All right. Plug in all that, and what do you get? We can plug it in, and you get like 8.43 times 10 to the minus 9 newtons. Or we're going to see some small numbers these days, so little n means nanonewtons. Right? So just a few nanonewtons of force. Okay, so that's really weak, right? That's like the weight of a mosquito's wing is about, that's how much force is between us gravitationally, and it's really real. Right? It's between us and me and you and everybody in here. So do you think you can feel it? Let's just think for a minute. Come on. You feel it, right? I need you to say that you feel it. So you feel that's just my cologne. That's okay. Whatever. It's called gravitas. If you wear a cologne called gravitas, whatever. I don't know. I haven't had any coffee. I'm going to die. Yeah, so this is really small, right? So the point is gravitational forces are really small, all right? They're really not big. So that's why you notice them when you're near really large objects, okay? So that is literally, it's just plug and chug to get the magnitude. So there we have the magnitude for calculating the forces